Hello, we are live. I adjusted my camera earlier, it's already out of place. Chat is not showing, or it is... Oh, a message just came in as I said that. I don't think it was showing though. Hello everyone. Okay, there it is. Somebody asked if it can run Doom, and it could. I think it probably crashes right now, because I've made a lot of changes since I built Doom for it last. But yeah, it should. Alright. I need water. I'll be right back. Okay, I'm back. I'm alive. Okay. Let's see. I streamed... What the hell is happening to me? Those vocal warm-ups didn't do shit. I... Okay. On Saturday, which is when I last stream operating system development, I was working on refactoring my file system, make a series of changes. So today I'm going to continue that. Yesterday, I instead worked on a game engine for a future game. I actually found a bug in the file system. I don't know what's happening. I was fine until literally I started speaking. But yeah, I found a bug into that file system, but it makes sense because I kind of left it like not fully finished. So I gotta work on it. I gotta improve it. But there is another major bug, and it's the fact that the crash handler in my system crashes, which means that even if userland crashes, which the system can usually recover from by just quitting the application that crashed, it just crashes the entire system. Not ideal. So I want to take a little bit of time to fix that before moving on. I've had a cough for like a week. Did I transfer it to you through the screen? If it was the other way around, it would make sense because like you're seeing me and hearing me, but maybe. You never know. Also, sorry to hear you've had a cough. No, this feels like... I don't know. What did I do? I mean, I ate a kiwi like 10 minutes ago. Unless I became allergic between now and when I ate one like in the afternoon. I don't know. Sometimes I get coughs that last for a really long time. I think it's related to sinus issues. That's really fun. Last year, around this time of year, I was just like coughing literally all day. For a month. Around a month, I think it lasted. November was a really fun month last year. Yeah. Okay. Yeah, I don't know what's going on right now. It's not like I'm getting sick, okay? That part I know. I'm not getting sick. Okay. So, crash. The crash handler crashing is not a thing that you want happening. Now, is it? I'm thinking not. What can we do about it? Well, most likely the crash handler is crashing because it is trying to access a an address that is unmapped. Most likely that address is in low VA when it should be in high VA. That is virtual address. Because that's when it started happening. So this crash handler is actually crashing because it says system has crashed. This part works. This part is the one that tends to fail. And then it never gets to this part because this one keeps failing. Even though I have this syscall depth less or equal than 2, less than 2, it should not be crashing so many times, but it is. So after you stream like a few times before, sometimes I'm a bit tired at the time you stream. Really? I stream even an hour earlier for you at 6:30. For me, it's 7:30. It used to be 8:30, but with daylight savings, I find it easier to stream at this time. Alright, what can be crashing in here? This works with addresses, so that, most likely. Sleeping schedule is fucked. Sounds like it a little bit, yeah. Okay, why do I feel like I want to blame you? I want to blame the backtrace, which was already crashing sometimes. But also, probably crashing even more. Okay, these addresses most likely just need to be mapped to high VA, but I'll do that in a second. First off, I want to check that that is actually what's crashing. Now, how do I trigger a crash? Shouldn't be too hard. We're not in Rust. Print. That should be... Oh, that may give me a warning, and I have warnings as errors, so maybe it'll crash. Maybe it won't compile, No, it's compiling. Alright, we're good. So this program should crash. Hey, you were supposed to fucking crash the system. Wait, no, it wasn't. I commented out the part that I thought would crash. Yeah, that's a different crash. That's not related. 9 p.m. to 10 a.m. Damn. 13 hours? Alright, there we go. There's the crash, and it doesn't happen if I don't have these. So, most likely, you are the one crashing. Because this address should be in high VA. And this address comes from... Where does it come from, actually? I know where I set it, I just don't know where it's being passed on to this. Okay. For the process, that is actually here. And it needs to be fizz to vert pointer. That way it'll be mapped for the kernel. And you as well. "13 hours of sleep is not half bad. I wish I could. Not gonna lie to you. Wait, there's another place in which I should have mapped that. Did it work? It hasn't fully crashed, so I think it worked. Yeah. Hold on, that worked. I think. Yep. That fixed it, but there is another place where I should look. And that is... here, probably? Nope. No, it's called from the kernel. Okay, so that was the processes debug information that was being loaded to the wrong place. Now it's being loaded to the right... well, not really the wrong place, just it was mapped differently. Now I need to do the same thing for the kernel, even though it seems to work. If the kernel crashes, it's going to cause a constant crash, which I can actually check for. Instead of making you crash, we're going to make the kernel crash. Right here. Hey. Bro, what? I'm sorry? That didn't crash? Why didn't that crash? I'm so concerned that a buffer overflow like this didn't crash. Maybe C is an unsafe language. Does this speech even work? Do you not hear it? Yo, why are you not crashing? Subjester. Wait, okay. First time hearing that it doesn't... Wait. No. There. Okay.
K.
That should have played. Okay. Now, the funny thing is I didn't hear it. Okay. But also, if I hear it, it's coming out of my computer speakers, which is then being picked up by OBS. So that should have still been heard, but hey, whatever. The problem is now I don't hear it anymore. So... oh, I feel like there was extra setup for that one. What did I have to do to fix this? Okay, I think that. Please don't be like duplicated or something, 'cause that's just gonna be another pain in the ass.
K,
Okay, I heard it. I think it played.
K,
Okay, yeah, I think that's good. Cool. Why are you not crashing? I need you to crash. This is the first and only time I'm gonna say that. I need you to crash. Let's make it a function pointer if I remember how to do that. I never remember how to do a fucking function pointer, do I? That's not it. It's probably void. Let's do a void. Okay, like that. Incompatible integer. Okay, I just need to convert it. That's not a problem. Just do a little conversion for you. Right there. I tried a memory. I tried a lot of stuff. It just didn't work. Actually, this should work. Crash the system, please. Amazing. Okay, there we have it. Crash handler is back to not crashing the entire system. Now, I thought I would have to debug load. Here it is. I thought I would have to load these into high memory, but apparently I don't have to. Fopen malloc. Oh, malloc has already been put to high place. It already has friends in high places, so we're good. All right. Crash handler is fixed. It was the process crash handler that wasn't working. The system's crash handler was actually working fine the whole time. We're just going to put this fix in the main branch, because it's quite an annoying bug to have to deal with if you're trying to use the system without my latest changes. Crash handler, crash fix, push changes immediately to main. Boom. You have to use a stdio console for that. Okay, I need to delete this branch, by the way, because I'm not using it anymore. Boop. Oh, it doesn't exist anymore. I figured. Alright, same for you. Gotta delete you. Also doesn't exist in remote. That's about right. And same thing for you. You gotta go. And that one did exist. What was in that branch? Oh, this is old. This stuff is super old. Wait. Oh, okay. Yeah. I should probably also clean up these, but we're not gonna do that. We're just gonna clean you guys up real quick. Like that. So it didn't take a year to do it. If it doesn't take a year to delete a branch, if you don't make it delete a branch on the remote that doesn't exist. Okay, there we go. Now we have only 2 branches and 50 stashes. We're just going to close this little tab right here and we're good to go. Okay. So I noticed something when I was running my game yesterday, which is that you cannot open multiples of the same file right now. Most likely, that is because I made a change in how my file descriptors are created, which they all point to the exact same place. So, for example, this dude is walking around, but the other ones are invisible because their files didn't open. What's the most likely explanation for this? I am using the same file descriptor for all of them. If I use the same file descriptor for all of them, they all use the same cursor. If they all use the same cursor, once the file has been read once, the cursor is at the end, and you can no longer read from the beginning. So, technically, the wrong thing about this is that all the files, once you open a file twice, it gives you the exact same file ID, which is wrong. That's the real problem. But on top of that, there might be, like I said, multiple branches, not multiple branches, multiple ones sharing the same cursor, which I wouldn't want to have happen. So I want to check real quick that that is not happening. That shouldn't be what's happening. I don't think. Anyway. But, yeah. One thing I can do, though, is make sure that once a file is open, the indentation here is weird. What's going on? There, that's correct. All right. I set the cursor back to 0. I don't think this is going to change anything because what I said about the cursors, I don't think is correct. But I have had some cases in which if you don't initialize your file descriptor with blank values, it gets garbage values in it. So better off zeroing it out myself. No, that didn't fix it. That's about right. Okay, that's not a problem. Oh, because the descriptor that's being used... Okay, I understand. Yeah, hold on. The cursor being used to read a file... No, it's this one. I don't know what I'm talking about. Close file? When is that gonna be necessary? There's a lot of RAM. Just download more RAM. Why do you need to close files? It's kind of a weird question. What do you know? There. Happy? Another thing I noticed just now, the cursor is being updated by the read file function, not by the write file function, funnily enough, which is right now only implemented in one place. But in that place, the cursor is being used. So this is a little weird. I feel like the file system is all over the place. And I'll probably want the file system modules and the file system itself, so this one, and then the actual like module that handles the part of the file system, that is the FAT32 driver or the process or whatever it is, to not have to handle any file descriptor stuff. To just work with global files, essentially. So a module is told, hey, open this file, write to this file, read to that file, read from that file. And it doesn't care about cursors or anything like that. And the file system API, which is this file that I have open right now, is the one that actually handles cursors and whatnot, and then instances of opening a file. So you can open the same file multiple times, but it always points to the same place. That is quite a big change to make, to be completely honest. But it might be worth it, because yeah, I feel like it is all over the place right now, and that's not great. So I like that this cursor is being increased by the amount here, but is anyone else doing that? Because then that's gonna lead to, see? Okay, when writing a process, the cursor is being increased by this. That's no longer gonna be the case. But also, what is this? Oh, this is not internal, external. This is not a module, so that's none of my business. Same for deflate. Actually, that's a different type of cursor. That's for the deflate reading. Same for this one. Same for this one, and same for this one. Okay, so I was right. Okay, you're gonna tell me the amount written. I will return it, but I will also increase the cursor by the amount written. Okay. So now I don't have to do it every single time. I'm gonna test it with the terminal. If it works, I'm going to commit. Which the terminal does not always work. That's weird. Unknown command cat. It fails to... Oh! I just realized why processes are failing to open. Because of the file descriptor stuff, opening a file is probably failing the second time around. Okay, that's probably what's happening. So 9p may be struggling a little bit to yeah, to open a file a second time. I also noticed it when the user process crashed. The first time it showed the name, the second time it showed the default name, which means that the package's info wasn't being loaded the second time around. And the same thing is happening here. The first time it manages to open the cat process, the second time failed to open file, and third time as well. So that makes sense. Now I just need to understand why it is happening. It should actually tell me. 9p is not returning any errors. This failed to open file, where is that coming from? Because the result of the F open is not success. Okay. Shouldn't this be printing or this be printing if the result is not success? Oh no, because this can fail as well. Oh my god. Right, I'm using a hash map, which already has a value with the exact same hash. So it's failing. I'm assuming. Hello, MX. Let me see. I think this is what's happening. I mean, logically, that's what I think is happening. Honestly, the best thing I did is separate this library that provides printf and whatnot for the kernel and the user space so that I can use it from the kernel without triggering a context switch. Because that was creating a whole lot of problems, but... Okay, let's see, I open this, I close it. The second time it doesn't work because... yep. It fails because there already is a value with that. Okay, and what values can you possibly return? -1 means error, 0 means it already exists. Okay, so all I need to do is just check if the value is 0 or 1. I will accept it. Can you please just go back? And then result equal to 0 or result equal to 1. We're good. And that way we'll allow opening multiple files. I'll need to do the exact same thing in the FAT32 driver, but it works, which means I can do cat dev console. I can do again cat dev console. The second time it didn't work. Bigger or equal than 0. Yeah, thank you. Oh, boot. Okay. Console processes are being loaded from the FAT32 drivers, so the fix works. I just haven't applied it to the correct driver yet. Well, I applied it to one of the two drivers. Now we need to apply it to the other one, which is here. Is it literally the exact same code? Just the name of this variable changes. And then the rest of it is the exact same. And now that should work as well. Okay. So it turns out this wasn't just a problem that was happening because of the way that I left the system in like a half state. No, it's completely different than that. Okay. So I open this, I close it, I open it again, I close it, and it loads files every time. And then I can do cat dev console and cat dev console. Overflow, huh? Overflow, you say. Is it actually? Because yesterday I think I found a fake overflow. Or rather, something that's just causing a huge allocation. There's a chance that there's actually an overflow. No, that doesn't feel... Oh, no, wait, hold on. I think it worked. Yeah, this still crashes, but that's a different story. Not sure what's going on there, but one problem at a time. All right. The fact that it crashes is actually means that it did work. It was able to find the correct value there. Wait, what did I change in the file system? Oh, yeah. Yep. And yep. From kernel. Oh, from module to fs driver. And another thing that I did in the file system is fixed hash map logic for FAT32 and 9p. There we have it. Hello, Erkut. All right. We're doing good. Making progress. Technically, my file system driver works now. The main issue, the main limitation that it has is that it gives you the exact same file descriptor for the exact same path. whether you're opening from one process or another, whether you are opening multiple times in the same process, or whatever the situation might be. Instead, we want different file descriptors to indicate different instances of a file. But this is good progress. It works now. You have multiple characters back in the game. Cool. Before just giving each a different descriptor. Okay, here's how it works right now. I should probably have some drawings for this. Scroll back to the content. Somewhere. Here. No, here? Yeah, this. Okay. If this is the path to the file, I can't say I understand this, what I drew here in the slightest. I can't say this really makes a whole lot of sense. Okay, well, we're starting over. The plan is... Can't I make this eraser a little bit bigger? This is kind of annoying. All right. When you have a file, then that file is owned by a module, which is in this case the... How can I move you to the back? That's probably, yeah. Also, there. The process is owned by, in this case, the scheduler module, which is the one that handles processes. So it's the one that has, access to the process's information and provides the proc file system, part of the file system. In the scheduler module, this file is given currently an ID. Which is this one. And this is the exact same ID that I am returning in my file system module. Well, it's not really a module, so in the file system itself. When you open a file, this will open this file if it isn't already created and return this exact same global ID. So the file ID is the global ID, which means that you open the same file multiple times, you get the same file ID, even though you're getting different instances of the file. And you're actually getting different cursors for the file, so that's good. But it's still not ideal. And there's a bunch of stuff happening that isn't ideal too. For example, some files... because the file system is set up to open files as files, but also things that aren't files as files, then it can be a little bit tricky. For example, you can go to this path, proc8 state, and it will tell you the state of process 8, whether it is running, whether it is terminated, it is sleeping, mostly just running or terminated. But yeah, this gives you 4 bytes of data because it's an enum. It's always the same 4 bytes. So here there should be a little flag called ignore cursor, which it currently has inside of this module. Same as the file global ID thing is inside of the module. I have to say I don't love that. And yet it provides, ironically, modularity because there is a hash map of all the open files that a module has. And whenever you're looking for a file within that module, you only have to look at the files for that module. If there's another module, then it has its own map. But I should standardize. Where is it? In the schedule module. Scheduler module. Where is that? Here. Here. This structure, which is the one that is defining the file within the module itself. So the global file. Essentially, this definition is handled by this file. It tells us if the file is read-only. It tells us if it can be, if it should ignore the cursor or not, if the process ID, that's probably not going to be used anymore. That's just a thing that I created because I thought I might need it, but I don't. Not in here anyway. I don't need it. It then keeps track of the file ID associated with that file, and the file size and the buffer that contains the information of that file. So this should not be only for the scheduler. It should be for all open files. So all the modules should use this, which means that you are being moved to the header of the file system, and you're being renamed to module file. Likewise, it should be in a hash map. So real quick, they're already in hash maps here in the FAT32 driver and the other driver, but that. So instead of being a linked list, which is not super efficient, we'll put it in a hash map, which is more efficient. Okay. If the hash map doesn't exist, then why the fuck wouldn't it exist? We're just going to put this in the initialization of the module, which is start scheduler. The code that I just copied is gone. Not sure what I did there, but... What the hell? I'm trying to copy the deleted lines. I'm pressing that. Okay, there we go. Let's not have macOS have issues copying like Linux does, please. For the love of God, please. No, not that. And then you're going to do with the init scheduler module, which will do that, and then it will start the scheduler. And C hash map create with an initial capacity of 64. Should be more than enough. Okay. This is now a module file. So you need to have the file system. Okay, I just gotta replace this C hash map with a C hash map put into proc open files. The value is file. The key is the file ID, which is a uint64, I believe. I don't need this function anymore. And then I gotta replace this search with a C hash map find, I believe it's called. No, get proc open files, with the key being a FDID, and its size being the size of a uint64. And that will return a void pointer, which I'm just gonna check here real quick, this other file system where I've already implemented it. It's just a pointer to the file directly. So that saves me these 3 lines of code. And a very similar thing is going to happen here. Not to say the exact same thing is going to happen here. There we go. Okay. There's even a race condition that makes it so that the cat command doesn't always work. Now it is always working, so that's pretty cool. That was helpful and necessary to make sure that it works like I expect it to. Actually, I'm going to make a little change. This is not going to go here. It's going to go directly in the modules thing. That way, I don't need that import. Where was it? Here. I don't need this import. Saves me that. But also, size of file ID. I tend to not do that all that often. But not a bad idea. But before I do that, I'm thinking I'm gonna be writing the exact same code to get a file everywhere. So it's probably better if I just straight up put it here. When I open the file, oh, I'm allocating it. Okay. Yeah, that's good. That's good. That's good. Oh, shit. All right. The fix that I just did is getting double fixed. Because I genuinely forgot that bigger or equal exists. Otherwise, I'm returning a driver error, I believe. What should be a 0? No, it's a 2. A 0 is success. Oh no, not POSIX compliant or Unix like. I mean, Linux like. The only thing that's Unix like is that everything is a file. And, yeah, that's pretty much it. Okay, I was thinking about like how can I possibly simplify the process of opening a file, because I'm going to be writing this line of code, this line of code, and the same one but here, everywhere in all my modules. But at the same time, it's like, yeah, I am going to be doing that. But if I replace it with something else, it's just something that encapsulates this. It's going to be the exact same thing. So kind of who cares? Okay. Just going to check that nothing broke. Did I just type make roux? And it worked? RuPaul is just that powerful, huh? Okay, cool. A stupid race condition kind of prevents me from testing this properly, but it does do what I want it to do. Well, I can always test it like this, probably. Not sure if that worked. Because if the process was allocated with less than one argument, yeah, that shouldn't really have worked, should it? Oh, right, race condition and all. Yeah, no, that doesn't fix anything. Okay, so the fix that I did in the previous commit is better now, but also I had to to change it a little bit essentially. Okay, I think there might be a way that I can simplify not that, but this. This code is pretty much always going to be the same. I'm pretty sure. Wait, no, this is this is the generic one. No, it's not always going to be the same, is it? Yeah, never mind. Never mind. Okay, there's an ad starting, so I'll be back in 3 minutes. And I'm going to do the next part of this, which is this new module file thing, implementing this in the other two drivers that I also showed, and any other drivers that use read-write, which is not a lot, but still a few. All right, we're back. And so is Penguin, according to the chat. Okay. I know what I just did. I remember what I just did. Totally. I didn't just have just get amnesia in the last 3 minutes. No, okay. Trying to standardize my file system that it's divided in modules right now. And it's going well. Now I just need to implement what I did in one module in all the other ones. So not this, but rather no, create a module file file. Why am I pressing the wrong keys all the time? Where were we? I lost it. Here. Alright. Okay. I don't want you to have the file buffer directly. I want you to use the M file now. Likewise, you won't be using that anymore. You'll be using the M file. Which is a pointer. And you'll use the M file buffer. Okay. And you'll also... I'm still thinking of a way to standardize this, oh god. No, we're good, we're good. Let's not overcomplicate things. Port for Minecraft? Hell no, that would require me to port Java. You think I'm porting Java? Maybe. I say that out loud. Okay, you open a file with an M file. Now, why are you complaining? Oh, I didn't cast it, did I? And is there no write file functionality here? No, straight up there isn't. Good to see that. Okay. Okay. I need to fill in some information for this. That would be that the file size is given to me by the size variable. The buffer is given to me by the file pointer. I still need to port it if I want to have that. We don't ignore the cursor. Read only is a property that I'm currently not using. That is a little bit silly. I need to remove it. File size, file buffer, ignore cursor. File ID is the only one missing, which we get from the descriptor because we just set it over there. Cool. All right, that's how you do it in the Vertio file system. And to do it in the FAT32 file system, it's about the same thing. Literally the same code. You no longer use file, you use buff. And the size is buff ptr size. Your memory page is the native libraries at glfw, probably some other native bindings, and OpenGL. So you would have to modify those and implement OpenGL. Would I have to modify them, or would I just would I be good with just wait? Okay, native libraries you're saying, right? Okay, so yeah, you're right. I would have to do that. Oh no, I just have to make my own Minecraft clone now. Oh no. I think the only dev YouTuber that hasn't done a Minecraft clone, so it's about time. I'm way late to the party. Okay, what is the name of my memory page? I'm not seeing any allocations happening. Here it is, FS page. There we go. That simple to make that change. Now we need to use the M file. The M file. You use the M files a buffer. Okay. And the thing about this is that the size of the file depends on, well, the size that you're going to be reading depends on the current cursor, the size of the file. Like it says here, we're not checking the cursor's validity within the file. Exactly. So about that size, if cursor, that would be if descriptor cursor is bigger than size, just return 0. That's a check that we can do immediately. Hell, you know what? There's a chance that I can just make this function common between the two file systems. Are they inheriting from the same FS driver? Alright, let's not do that right now, but yeah. Jester doesn't want me to do that. He's complaining. I mean, Minecraft runs in the Java, in a Java virtual machine, so in that sense, I could port it and all of the Java applications that I want, but I would need to port that, and that feels like a pain in the ass to port. Because it's Java, you know? Can't imagine that the internals are particularly pretty. Okay, that's check number 1, and check number 2 is that if size is bigger than the file size, which we now have access to, minus the cursor, then the size will become that value. Unobfuscated versions. Only in snapshots and experimentals they have that? Right. True. Okay. So these two checks I'll also want to introduce here. Yeah, this function is virtually identical to the other one, isn't it? Well, what changes is this pretty much. That. It sucks that I'm repeating so much similar code, but not identical code. That really sucks. Because it is similar but not identical code. If I put a function to replace all this, the function would be about the same size. So it's not really worth it. Okay. Do you guys work now? This one works. Ooh, did that crash? Translation faults. There's still a lot of these happening, Jesus. That's so annoying. I'll need to really finish working on virtual memory and get it working perfectly. Because it's not currently working perfectly. Clearly it crashes very often. Okay, there we go. Okay. And now the exact same thing that I just did, I'm going to have to do for any file system that writes, such as audio. And scheduler is the only other one that really writes. These two I already did. Oh, console. Except console is a very minimalistic one. It doesn't even use a file necessarily. It just uses a buffer that it holds in memory. So, okay, that one is exempt from that. The audio files. This is the only one I'm going to have to change, really. Because, like, when you open an audio file, oh, you're not keeping track of any files that are being opened. Same thing, it's just a proxy for a buffer. A very specific one. There's no actual files. Pretty sure the file descriptor is not really used. You have the option of using the ignore cursor now, but that's not a thing. Okay, that makes my job a lot easier because in terms of writing, I don't need to port any more. In terms of reading, I have probably a few to copy. Read bin does nothing. Why is that a function? Oh, right. Because when binaries, or like the bin folder was, instead of being an actual folder in the disk, it was a virtual folder. Then I created read-write functions, but I don't want those anymore. Until I create something like symlinks, because, yeah. I don't know how I'm going to handle that yet, but yeah. Random also doesn't use traditional files. That's convenient for me. That means that the only three places in which I use files are the three modules that I just did. So that's convenient for me. I don't have to do it a million times. Did we configure virtual memory or did we put it on the back burner? It's mostly done. There was an issue with the crash handler crashing. I fixed that at the beginning of this stream. There seems to be issues also with... I'm not sure exactly what is happening. I don't feel like debugging on stream, to be honest. But opening one process after closing another feels like there's either some stuff being unmapped that shouldn't be, or some stuff that should be unmapped that isn't. Probably the second one. And so that's leading to some crashes in some specific cases. Like when you try to run the cat command twice, or when you open the demo process after you open the ghost game, because I think they're on the same address. I get a bunch of memory already mapped errors, and then it crashes. I may know what's happening a little bit. I'm not entirely sure. Okay. That's that. Oh, there's also sread and swrite, in case I'm using these anywhere. I thought I implemented one, but maybe I just implemented simple write. I genuinely thought I did. Oh, I did. Or when a module was interprocess communication, was using interprocess communication, it wasn't interprocess communication. Because these same modules, driver modules, are used for interprocess communication, which, while I'm at it, it says here, for IPC, rename system module and create a dedicated loading function that attaches a module to a process so it can be cleaned up. It is now a system module. We can make that change easily. Yeah, so when I open this process and then I open this one, it crashes. And when I open the cat process twice. Most likely there's some memory that's not being cleaned up properly, so. Holy. I made a change in one file, but it really reflected on all of these. Why are you spinning out of control? Yo, is source tree like having some issues lately? Because this morning at work, source tree was also doing the same thing. It was just randomly freezing. I've never seen it before today either. Okay. There's that one. There's some more changes I wanted to make to the system, renaming stuff. So I think I'm gonna do that just to ease up a little bit. Do something not super complex. Because I think I got what I wanted done. But now I need to instead of having global files, have instances of files for safety reasons. Okay, there are some more changes I wanted to make. Okay, so the console. The console is no longer going to be at dev console. It is going to be at just console. And it was never really checking for anything. As long as you made it to /dev/console, it would open. You could do /dev/console/hi and it would still work. Now you can just do /console and it'll work. Any others that are working like this? Yeah, graph. You are now doing just graph. And then what about the random module? The Linux community is more than welcome to cry about it. Oh, random was already at /random. Proc can stay as proc, bin can stay as bin. Let me just check all the mount points that I have right now. There's audio, bin, console, random, disk, boot, shared, graph, in, net, and proc. Looks good to me. Okay, let's see if it works. You can... that never was gonna work. Yeah. Okay, there you go. There you go. Okay. Oh, that was a very simple thing to do. There is another thing that I wanted to rename. This one, Linux community, get ready to cry again. Cat is such a non-descriptive name for a process. For the love of God, I hate it. Does it? Is that all I need to do? I feel like just searching for cat is not super helpful. But it seems like there are no references to cat anywhere. It probably would have been faster for me to just run it and see if it works. Hey, Ice Dave. Wait. Yeah, clean the process. Concatenate Catenate cat. That's funnily enough, that's the opposite of a concatenation. I'm not sure why it says process ended. User process cat allocated. So there are some references to cat. You still have some references to cat. I swear to God, you're lying to me. Now I'm probably just not clearing the folder. Yeah, cat is still here. That's the problem. Get out of here. Jester, are you happy? November 3rd, 1971. 54 years ago. Yep. Unknown command cat. And even though there's a race condition that makes it so that this doesn't work most of the times, that's what it's going to look like to read a file. You say, read. Linus? No? Don't kill me. No! Alright. I hear a meowing and scratching coming from my front door. And an angry Finnish man. I'm not gonna Google him again to make sure that he's Finnish. I feel like I looked it up once, I forgot, but I think he is. Alright. Bin. Cat. Read. I feel good after doing that. I was so annoyed by cat. What would have been really funny is if that fixed my race condition. Just something about the name cat just broke it. Did you see the guy that made a YouTube channel just to upload his 2-hour long rant about how bad C++ is? You seem like the type of person to do that with Unix. Hold on, because I did see that. I feel like... Is it this guy? It's this guy. Yo. Fucking amazing, honestly. I mean, 100%. He's got a point. I need to watch this. I'm gonna fall asleep to this later tonight. Would I do the same thing about Unix? No. But maybe like a 45-minute one. A standard little short one, you know? Yeah, that I could do. Okay. So. Did I end up drawing anything useful here? Kind of, yeah. Okay. So my scheduler module and my FAT32 and 9p modules are opening files using a global file ID, which means actually if you already opened the file, they will just open the file again, which is kind of stupid. As someone who is deep into the modern cutting-edge C++ versions, I agree with every single point of his video. See, I wanted to make a compiler that could compile my operating system. And then I remembered, shit, I have some C++ in here. But I have some very standard C++. So I was wondering, like, should I just make it so that it just converts that C++ to C? And then for that matter, just fucking use that? There is some inheritance stuff happening, but genuinely, can it be done? I mean, can it be done? Yes, it can be done. That's actually essentially how Objective-C works, by the way. Objective-C, shitty language. In terms of syntax, shitty. It looks like this. It's been years since I've written Objective-C, so don't quote me on the syntax exactly, but it looks a little something like that. And this is just allocating a memory for a class and then initializing the class that's been allocated. I think that's how it works. But internally, it just looks like... Well, actually, you know what? Let me use another example, like C print value. I don't know, right? Like that's the function that I want to call. Internally, this translates to something like this, I believe. So it just translates to a C function called Objective-C message send. Is that the actual name of it? Yeah, Objective-C message send. I spelled it wrong, but that is how it is. So this just translates to this. And if I do make a compiler that compiles my operating system and I have to deal with the C++ parts, I'm just going to do that. I'm just going to genuinely turn it into C. Because, like, fuck C++. It does so much stupid shit. It's so stupid. It's so annoying. I hate it so much. So most likely I'm just going to do that. And it's funny because in my first video, when I mentioned using C++, I was like, yeah, because I want to use inheritance for, you know, multiple drivers for multiple devices, having common functionality and being able to call their functions and whatnot. And people were like, you know, you could just, if you didn't want to use C++, you could have just used, essentially recreated what C++ does internally. And I was just like, yeah, but I just used C++, so let's not overcomplicate it. And now I'm like, actually, let's overcomplicate it. Let's. Okay. C++ is just overcomplicated by itself, so there's just no point. Okay, if we already have a file for that descriptor, then we don't have to return anything besides just returning a success and filling out the information for the descriptor, like the ID being the M file's FID, the size being the M file size, and the descriptor's cursor to 0. Well, that part I shouldn't have to handle here. And then just return a success. That way we don't open the same file a million times. We just open it once. Amazing. And then in FAT32, the problem with C++ is that even if you restrict yourself to features, to C features, you still get fucked by all of its hidden gotchas. That's exactly what I'm saying. I was using X19, register X19, to this line of code I missed. In the process saving, in the context switching process, and I whoops, didn't notice that. I'm using the wrong variable here. There it is. The fid. Parameter. Use the fid here too. And use the fid here too. I was using register F19 and then C++ was breaking in the weirdest way. I was initializing two objects. If I did that, it all worked fine. If I didn't initialize the second object, the first one broke. They were completely unrelated, but yeah, it just broke. Turns out it was because I was using that register for storing a variable, and in so doing, I was overriding the value of this. So the pointer to the current object in C++, which is in register 19 in ARM, which is really stupid. But anyway. Now I'm only using one register. That gets completely overwritten in the context switching process, so there's probably a way to make it so that it doesn't get overwritten at all, but yeah, there's one right now. Because I'm also doing stack, changing the stack a bunch of times, or in a bunch of different ways. Context switching and virtual memory are hard because they're abstract concepts. So if it works, I'm not going to refactor it at least until next year to make that tiny little improvement that I really don't need. You can run apps with optimization now. That's all I care about. Okay. What happened there? What if I deleted a boot while system is working? What do you mean? How can you delete the bootloader while the system is working? And the bootloader already did its job if you're able to delete the bootloader, so you'll probably have a hard time booting into the system the second time, but nothing's going to happen while it's running. I think you're also going to have a hard time deleting something when the system is not running, to be fair. Well, virtual machines. Oh. Philosophical question. Should I have done that for 9p? I feel like the answer is no. I should have done it for FAT, but not for 9p. Because the version that I have in RAM for FAT32, which is in my local disk, is mine. Even once I implement writing, I'm the one who controls the contents of the file. So if I write, I update the one that I have in RAM, and then I update the one in the disk. It's very unlikely that the one in the disk gets updated without me knowing. So there's no point in me opening a file multiple times. But in 9p, it can be modified externally. And then it would make sense for me to modify it externally. So this change is getting undone. Not modified externally, but like reload the file. If I yeah, because I can modify the system from the host, the contents of the file from the host system. So those are technically not files that I own. They're owned by a different operating system that is sharing them with me. So there we go. I mean, if you delete a file, two things are going to happen. Either you already read it and you don't need it anymore. In which case, next time you boot, it's not gonna work. Or it's just not going to work in the first place. QEMU just broke my inputs. Beautiful. I crashed the Windows driver. Are you sure it didn't crash itself? It's Windows. You gotta be open to that possibility. Okay. By decompile. Oh, I'm literally already doing most of what I need to do. Here. So I have a day job in Swift and Kotlin. I like Swift. I don't love Kotlin. Oh, I can't really fully refactor this to be C plus C only because of this file system driver stuff. But I can refactor it to use a hash map. And here's the thing. This open file descriptors is already doing what I said. The file system is globally keeping track of all the files that are opened. And then the modules are also keeping track of them. And like I said before, I want to have two versions of the file descriptor. The global one that indicates this specific file, and then the instance one, which indicates when I open that file. And when you open the file, it's a different instance, same global file. Technically, I'm kind of already keeping track of the open files twice. All I have to do is just separate the file IDs. That's gonna be a simple. The M file ID and the file ID are now separate. Why does everything just break when I set page alloc verbose to true? Oh, yeah, don't do that. I kind of just, it uses printf. So depending on where you use it, that's gonna break stuff. You know, if printf is not actually ready to be used, that's kind of a problem. But I mostly don't use that because it's also gonna make your system super slow by writing every single allocation that happens ever. So don't use that, essentially. Okay, yeah, you know what? I don't think there is a better way to make this more elegant, so goodbye to do. Linked list, you're out in favor of a C hash map. With an initial capacity of 256. And your allocator is just going to be a void pointer. There we go. Where we set the alloc to open files alloc. Open files free is just going to be the normal k-free function. Again, not sure why I'm doing this here when I should be doing it. here. I don't need this pointer anymore. Need to move you and you higher. Gotta do that. And then instead of push front, we have to allocate an open file descriptor. Let's call it OF. Calloc into the page. The size of an OF. Aligned to 16 bits and only for the kernel. Okay, and then we can do a C hash put open files. The key in question, that is the question. I can tell you the size is this one, and its value is going to be that of OF. But wait, what? There. What was that? Okay. Its M file ID is the descriptor ID. Its file ID is a reserve file ID. Its file size is the one taken from the descriptor. And the module that it belongs to is mod. And now the indexed key. Try new lines. Wait, why is one of the messages completely empty? That's weird. The OF file ID, not the module file ID, that's the global ID, no, the instance of the ID. Okay, so you're gonna do that. And then this has to be equal to 1 fs result success, otherwise fs result driver error. Right, and one more thing I need to do is I update the descriptor's ID with the OF file ID. So I'm translating from a global to a instance ID. Right there. And if result is not equal to fs success, return result, which is going to be an error. OS has been very slow on Windows. Not sure how they've implemented that stuff, I guess, but that sucks. Okay. When you read a file, you don't do it through this complicated thing anymore. You now do it through a C hash map get through the descriptor's ID and the size of a uint 64 key. What isn't slow on Windows is right. Yeah, but if it got slower, you know. I don't know what's happening with your QEMU installation. I don't know how much of that is on me. Okay. There is that. And we can avoid this now. We can access there. That simplifies things quite a lot for opening a file. The exact same thing happens here and then here, but one thing that I'm missing, is that I need to update the descriptors ID, which I first translated it from a global to an instance. Now I need to translate from an instance to a global in order to talk to the I can't really do that now, can I? I can create another one. What do you mean you lost your cursor? I'm so confused. Damn it. It is struggling to know the difference between this file and this file. Let's call this one an O file. Hey, Stony. What is your damn problem? Cursor and size and then cursor. Are you happy now? Great. GFD. No, it needs to be a pointer like that. Okay, same thing needs to happen here. And your name needs to change from file to O file. Okay. There, so now I'm doing that translation between the two. The instance and global IDs. And besides that, there is one more change I wanted to make, which is not going to be reflected right away, but it is going to be important. Keep track of the process ID that requested the file. Okay, and if I keep track of that, then when I get the file ID, I check if it's somehow different than the current ID, then you're trying to open someone else's file. That's not for you. Get your grubby hands off of it. You don't have access to it. Cool. Someday you'll work. Right? I really need you to work right now because I need to see that files are being opened and closed and then blah blah blah, all that stuff. It's funny that I changed the name and now I'm used to, there we go, it works. I'm used to typing cat so much and cat dev console instead of read console. Bye MX, who is now John's code. Not sure what happened there. Okay, cool. And then there's the simple read and simple write that don't use file descriptors at all. They don't have this problem. Okay, then just like that, we've implemented global and instance file descriptors, translating between the two. I'm a little bit concerned at the fact that there haven't been any crashes, any bugs, any features not working throughout this entire stream. It's been 2 hours. I changed quite a lot of stuff and it all just seamlessly worked, which means that either I became a good programmer or some hidden bugs have appeared and I haven't noticed them. Place your bets. Okay, honestly, it looks like I've done it. I've done it again. You have become the perfect programmer? I was just thinking a good programmer, but okay. All right. Well. Is it raining again? Okay. Cool. So, officially, the file system now works like I said it was going to work. When you open a file, you are given a file ID. That file ID is unique to that specific instance of the file. When I open the same file, I get a different file ID, but both of them point to the same file in memory. Both of them point to the same global ID. And that is quite convenient. Now, this whole thing started. I kind of forgot about this until I saw the tab open for Unix pipes and anonymous pipes, I believe, and stream-oriented programming. And the 3-body problem, I'm going to close that one. I might wanna, look into implementing pipes now that I officially should be able to, now that I have global IDs. But there is an ad coming up, So I'll be back in 3 minutes. Okay, we're back. It took me genuinely 5 seconds to find my cursor so I could start the stream again. It was lost. But luckily Apple has this thing. It just makes it big. Okay. I'm going to be good about tab management because I have a ton of tabs here. No, I don't have a ton of tabs, but I want to close them before I get to a ton of tabs. For example, I'm not looking for a job at Project Zomboid, so I'm going to close that. I was just curious as to whether they were hiring or not. I am not interested in writing Objective-C, so I'm going to close that. I am very interested in this, although I want to watch it on my main channel. I mean, on my main YouTube, not on this one. So, I'm just going to save this video to my watch later. And I'm going to watch it later. I don't think I need anything from my own system. And I was going to do some research on Project Zomboid. I already did that, so I'm closing that. Look at that. This is from the game stuff. This is from the game stuff. This is an old commit. Okay, that leaves me with the important stuff. Would you look at that? 5 tabs. The RAM, hold on. Yeah, I heard my RAM breathing a sigh of relief. But um I was talking about implementing Unix pipes. I should do that. I should do that. What the hell? I should do that. Yeah. Okay. Well, not Unix pipes. Pipes. Essentially, you can link 2 files together, and when one file gets written to, the other file gets updated with that content. It's Jester with a J. Don't offend him like that. He's not British. He's also right there, sleeping. No, he's not sleeping. He's side-eyeing me. To this day, actually, I wonder, I'm gonna ask chat, does anyone know what Jester could possibly be a reference to? Because I don't think I've ever had anyone actually tell me what it was a reference to. I feel like if anyone might know, it might be an online community of people who watches streams of people programming. In the meantime, is pipe the name of it? Yeah, man pipe. There we have it. Let's research the man pipe. A topic with which I am familiar. I'm reading pagers and fax machines here in the manual. I'm hating it already. He's the funny one in your home. Yeah, definitely. Okay. The pipe demon process. That's even better than pipe man. Is the pipe demon. Okay, the pipe daemon processes requests from the postfix queue manager to deliver messages to external commands. This program expects to be run from the master process manager. No, I wanted the assist call, I guess, not really the process, which is why I'm not sure why I was looking for it in the terminal, but let's call for the pipe. What happens when you call for the pipe? Why is there a pipe 2? They have a new one? I didn't know there was a model 2. Pipe creates a pipe. An unidirectional data channel that can be used for inter-process communication. The array piped is used to return 2 file descriptors referring to the ends of the pipe. Piped 0 refers to the read end of the pipe. Piped 1 refers to the write end of the pipe. Data is written to the right end on the pipe, is buffered by the kernel until it is read from the read end of the pipe. For further details, see pipe 7. Interesting. So, oh yeah, but that's reasonable. I was thinking, yeah. I'm glad I read this because I was gonna implement something really stupid. I mean, yeah, I was gonna implement something really stupid. Never mind. No, I'm not sure how to implement this. All right. The rest is not really relevant. Okay. Is this just the oh no, an example of opening a pipe. Okay, let me see real quick. Skip. Here we go. No. Where is it? Where's the actual pipe command? Oh, here. Using the pipe FD, which is taken from where exactly? It's empty, isn't it? Holy hell, that's complicated. I wanted to create pipes so that I could avoid this boilerplate code, and now I'm just doing the same thing. Okay. Thank you, Unix, but you've outlived your usefulness. Okay. All right. Let me see an example for which I had it, but I deleted it. My terminal process and my read process, which in a way is a child of the terminal, but not really. It's completely separate. Okay. The read uses one file, that is the file to open, and another file that is the reads output file. The terminal uses technically it also uses its own output file. Okay. So can I just make it easy and just do it directly like this instead of using file descriptors? I mean, I would still use file descriptors just like internally in the pipe command itself, not no, because pipe is not right here. Do I even need pipes right now? I mean, yeah, because I could implement it with a flag. Um, which will make it so that, okay, essentially read a file, write it somewhere else. Which is going to be a thing that I'm going to do a lot of. So it would be useful to have an option to use that. If there's no option, then no problem. And this would return a file ID. Right? And then but that's not really a pipe. That's just a copy command, isn't it? No, but it's automatic. Okay, that's what I'm confused about. Should I make it so that it just automatically takes content from one file, puts it in another file? Or should I make it so that you have to manually read from the file? Because that's what it does. You have to read from the read end of the pipe. So when it's written to the write end, then you're just creating a temporary file in the kernel which holds that data. When you read, you take that data from the kernel. That's cool, but what's this? Okay, unidirectional interprocess communication channel. A pipe has a read end and a write end. It's creating using pipe2, which creates a new pipe and returns two file descriptors, one referring to the read end and one referring to the write end. Pipes can be used to create a communication channel between related processes. A first in, first out has a name within the file system and is opened using open. Any process may be a first in, first out, assuming the file permission allow. Okay. I'm confused as to whether what I want to do is a pipe or not. What I want to do internally is that the kernel knows there's two files linked together. Unidirectionally. And this can be a single from beginning. We're not doing sub processes and all that stuff, so I'm not bothered with that. And okay. Now the way that it will work, actually the default way that it will work, so let's not bother with the options that it can have right now, is essentially you can create a pipe between two files. Whenever this file gets written to, then this file also gets the same written to. Essentially, the kernel opens this file for writing, this file for reading, and whenever this one gets written to, copies that into here. Then when you want to read from that, that's on you. When you want to read from here, that's on you to do it. And then the options that I was mentioning before is that you can also do it from the beginning. That is to say, if the file already has data that gets copied over when you create the pipe, even if the data was written before the pipe was created, or single, meaning do it just one time. Well, from the beginning, one time, essentially, because otherwise you're just going to copy nothing. But essentially it just means copy one time. That's it. But the default behavior is both files are kept open. When I write to this one, it also gets written to this one. And of course, there can also be multiple ones of these. Which means that, you know, it can combine input from multiple files like this. Would I call that a pipe? I feel like calling it a pipe, but I'm not entirely sure if that is the best name to give it. But I think I'm gonna call it a pipe. And it's gonna be a pipe. We're good with that. We're good with that. Okay. So what does this pipe look like? I don't get to create new header files a whole lot lately. It's exciting when I do get to do it. A pipe is just made out of two file descriptors. That's all that it takes. Additionally, I should probably take a process ID, let's face it. Cool. Where does file come from? I don't think it's from filesystem.h directly. It comes from types. No. Driver base. Nope. But it comes from here, files fs. Okay. Okay, you can create a pipe with two const char pointers. And potentially some pipe options. Okay, why do I struggle with typing the word beginning so much, not beninging? And okay, oh my god, I did it again. How are you gonna close the pipe immediately? No, let's not include this one. Okay, that makes more sense. You're going to use an out file descriptor. And you're going to specify options. Okay. This is what creating a pipe is going to look like. Essentially, you connect two files together by their file path. You're given a file descriptor in return to simply indicate what that is. And the default behavior is that any writes to the source get copied over to the destination with the default option or the additional option of copying what's already in the destination. Okay. The pipes are going to be held by this part of the file system. It's not going to be a module, but it is going to be held by this part of the file system. So the file system.cpp is going to be able to call this function when a file descriptor gets copied over, or when a write operation happens to a file, and then it is going to be able to directly copy into the file. Any files that have the file being written to as the source of the pipe. Likewise, we're also going to have to be able to close the pipe using a file descriptor. And okay, these two are part of the API. This one is not. This one's just for the file system thing. And then what else happens? Is close pipe gonna be unimplemented for a while like close file? I'll probably implement close file soon. You know. Yeah, totally. Totally. It shouldn't even be difficult to create, to implement. One thing about it though, it's gonna be kinda like garbage collection. No, we don't close a file until it is all of its references are gone. We can just count the number of references that there are to a file. Okay, I'm also going to create another function. Which I should also create for the file system in general. To close files. It's funny, the vowels in the word files and the vowels in the word pipe are the same. Totally important observation right there. Okay. Here's how it's gonna go. Let's do the connection real quick. Close. Oh, where was I going with that? Close files for process is going to iterate through the list. Can you do that? I don't think it can. Oh, for each. Look, would you look at that? It takes 3 arguments, and I'm not sure what those 3 arguments are. But good for you for taking those 3 arguments. So you're gonna do that. And then you're going to close pipes for process PID, which is gonna be a very similar thing happening there. Yeah, I gotta import the pipes stuff. And that's it. Don't I have to declare it extern C? No, because this is okay. No, never mind. No, I think I do. I think most likely, and we'll get a crash. Yeah, I mean, it won't compile. There we go. That should compile now. Hey. Oh, wait, I haven't actually implemented the functions, so obviously you're going to complain. I need to know what this function does, so I can start implementing closing logic already. It takes the map, a key, key length, and value. Okay, if file PID is equal to close PID, then this file needs to be removed. Oh God, how are you going to do that? Well, just going to quickly add a reverse function to this so that I can easily iterate through values, removing values in real time. How do I do this? I gotta change the sign of this thing too. Then I'm better off not doing it here and rather doing it. Yeah, I'm literally just using this in one place. If reversing, it's map capacity minus 1 minus I. Otherwise, it's just I. That's the easiest way to do it. I don't know why I was doing it the other way. Okay. So you're going to iterate through this array, and you're going to iterate through this array in reverse. And if the file... Wait, open files? Doesn't hold module files. No, I used the wrong type here. It's supposed to be this one. Okay. If that's the case, then you are simply going to c hash map remove open files keylen value. Why does it want the address to it? macOS for operating system development? Yeah, QEMU works on it. That's really all you need. I would recommend it. You want an address to it? There you go. All right, and that closes all the files. Amazing. Not that this does anything right now, but it will. Also, close PID is no PID, and then close PID becomes -1. So we make it N32, kind of like that. These functions are not doing anything right now, so they're the least of my problems, but nice to have them. Wait, I was supposed to do the connection to the other functions. Ooh, no, I didn't mean to copy that. What I wanted to do is called pipe update pipes for the O file M file ID using the same buffer and size that was just used. Except wait. Yeah. What I need to do is use this as the amount written. Okay. And what other functions do I have? Create pipe, close pipe. These are external, update pipes, and close pipes for process. Okay. The only issue that I have is the file path of the pipe. Which frankly should be kept track of. Yeah, I don't know how to do simple writes yet. Those don't use a file descriptor, so it's kind of complicated. They just use a simple path like this, and they don't. Well, right now, the global file descriptor that is being used by the pipes is yeah. Okay, that's good. I feel like I didn't finish any of the 50 thoughts I started there, so essentially the global file ID is just a hash of its path right now. That will change, and when that changes, this function needs to change as well. But that's not a problem for right now. It has this reserve fdgid path, and then update pipes for this mfid, not mid, mfid, the buff, and the amount written. Once I change this function to no longer work like this, then I'll deal with that in the future. Okay, all the connections should be done. Now it's time to implement the pipe.c, which includes the pipe.h and implements these four functions. How does it implement them? Okay. For creating a pipe, it simply needs to keep track of this logic for it needs to be kept separate from the logic for the other thing. Okay, so I need to have two open functions. One of them opens a global file, and the other one opens an actual file. And unfortunately, it needs to also keep track of the system module that it uses. Right, so it will return an fs success if it got to that point. And then you're going to do open file global using the path, the descriptor, and this pointer. And then that's it. Now the pipe can also call this function. Okay, so when you create a pipe between two files, you simply open those files. Open file global source. Okay, I need to import the file system if I want to do any of this. There. And I also probably don't want to use this. I want to allocate a pipe. Not actually gonna malloc it, but this is kind of what I want to do. Create a new pipe. Why is malloc? Oh, because it's not implemented. Okay. Yeah, forget malloc. Forget malloc. We're not gonna be doing that. Going to be p allocating a page size for the kernel. Read write, not a full page. And then we're going to kalloc into the pipe page the size of a pipe T aligned to 16 bits on a mempriv kernel. And none of this works because I don't have the right header. Just memory page allocator. Okay, cool. So we create a pipe. Well, we create space for a pipe. We then pass the right file descriptor to open the file for writing. And we do the same thing for opening the file for reading. If we succeed, we are also going to open the other file for writing to, using again the same pipe we just created. It's read descriptor, and oh, we're not keeping track of which module each of them belongs to. We don't care about which one this belongs to, but we care about when this one belongs to. And if that succeeds, we are going to save the pipe. And we are finally going to free the pipe if it fails. Return the result. That should be it. That's all we need to do. And when we succeed, we also need to keep a hash map for all of these. No, a hash map is not right because it's not guaranteed to be unique here. Then maybe it's better if I don't do something so stupid. Like using global file descriptors. And I just use the local file descriptors, which will allow me to use a C hash map. If there isn't a pipe map, we are going to create it. C hash map create with 250, a bit much, 64 initial pipes. And then we are going to see hash map push, put actually, the pipe map. The key, we're going to be using the pipe write file descriptor ID. And the size of wait. Maybe I do want to use globals. And in the map, but inside of it, linked lists. That seems like a slightly better idea. What do you mean? Like this file? This. Pipe write file descriptor ID with a key length size of a uint64t. If the list doesn't exist, we need to create it. Oh, yeah. Okay, let me see if any of this logic makes sense, because I feel like it's a little bit lost here. All right. There. Okay. So when I create a pipe, I'm going to open the files globally. I'm not using a file descriptor. I'm just using the global file itself. When I receive an update, like, oh, this file has been written to, then I am going to update all of the pipes that use that as the right end of the pipe. To do that, I'm using a hash map, which has a linked list as an entry, which contains the pipes. Yeah, which contains each of the pipes, each of the destinations. So that it'll be like this, and okay, it looks like this kind of. We have the write file and the read file. When I write to the write file, there's an array of these read files. I go through it and I update them. And I can just access the file directly. Okay, that makes sense. All right, there's an ad starting. I'm just going to finish writing all this boilerplate code in the meantime. Was that the stream? What was that what? Not sure what you're referring to. Oh, it lagged for a few seconds? Oh yeah, it did. I just noticed now. Okay. Am I still live? Okay. Let me take a break during the ad, because my connection is not the most stable right now. Now, you know what? Actually, I'm close to being done with all this, so I'm just gonna finish it real quick, because otherwise... Okay. I just create a list, and then we just wanna see linked list push front this list, and the pipe is the data that you want to push to it. Okay. All right, so I create this hash map. I look to see if there's an existing entry in it. If there is, good. If not, I create it. I add the current pipe to the list, and then I insert it into the array. So now we go back to using the open file global, because I'm not using instances of file descriptors. I'm working directly with the global files. And now I should be able to see linked list for each. Well, it has a for each function, but I'm probably not going to want to use that. No, maybe I do. Maybe I do. Yeah, I do. Okay, in this case, I actually do want to use that. Okay, I'm going to want to get the C hash map get from the pipe map. If there's no pipe map, we're done. There's nothing we need to update. If there is a pipe map, we want to search for values that have the global ID for the right file, which is the size of a uint 6014. And then we want to use the address here. That is going to be the value of our C linked list. If there isn't a list, we're just going to return we didn't find anything. If there is a list, on the other hand, we're going to want to iterate through that list and write what we just read. Okay, no, I don't want to use this function. Okay, the ad is over. It ends a lot faster when you're not waiting for it to end. That's convenient for me. Okay, so we're going to iterate through the list, and for each of the entries, the entry should be a pipe, right? For each of these pipes, we are simply going to check that all the data is valid, and if it is, we are simply going to delegate to the read module. We're going to tell it to write to the pipes read file descriptor using the buffer and size we just got. There's another parameter here. What would that be? What would that be? The file offset. Why is that a thing? Oh, wait, no, we do need it. That is what we are going to do. And then closing pipes for a process is going to be quite hard to do. So I'm just going to do this for now. Okay. How do I test this though? There's nowhere in which you write right now. Well, can you write to account? Well, I can just enable a random write function. Like test write. Okay. So I can now, for example, pipe the console to the random and see if that works by just printing wrote to random. And then, because it's going to be null terminated values, we're simply going to write that. Cool. So if I did everything right, I should be able to pipe the console into this test write, which goes into random. Now, there is a kind of major problem in the way that the cursor works, which I just realized now. It's not kept up to sync whenever somebody writes, which means that I'm starting to realize why Linux doesn't do it like this. Okay. Like if my cursor is here, that's the end of the file, but you write past it, my cursor is still here. Now I'm going to write here when I intended to write to the end of the file. So that is going to be a problem. I most likely will want to seek to the end of the file. But it's not functionality that I have currently implemented. So I'm just going to put a to do here. Okay. Now to test this, I need to do it from, let's say, a user process like the boot screen. So that would be in kernel processes, boot screen here. Include the file system, and you're just going to create a pipe between /console and slash random. I haven't done pipe options yet, so that's kind of a problem. And I also haven't done the file descriptor stuff. I forgot to do that part. Sucks, doesn't it? Yeah, I should have... Okay, this file needs to be open for writing globally. No, for reading globally. The other one needs to be open for writing, so it's an instance of the file. So this whole read mod stuff, not needed at all. So instead, what you need to do is write file with the pipe read the buffer, the size, and this little to do. Okay, that was a simple thing to do. Just need to get rid of this now. And I'm also not keeping track of who owns the pipe. Also, I do need to specify a module here. Whoops. That. And what else? What else is missing? Oh yeah, filling out the file descriptor. Which is going to be filled out with the values from the pipe. Here. Okay. And also to do options. Because I haven't included that stuff yet. No crashes, but it failed to load a file, which is kind of crazy. It failed to load the configuration file. How did that happen? Failed to read header file. How did that happen? That is... Wait, I didn't even finish writing this in the first place, so that... Whoops. I must have broken something. Well, yeah, I did. Okay. I knew this was gonna be a problem. I did this wrong. This needs to be a pointer to a pointer, so that I can write its value. Which is crazy. I hate doing stuff like this. Feels dirty to use double pointers. Kinda is, too. But it is necessary. What are you gonna do? We're back. We are so back. Okay. Now, for actually doing this thing, I need a file descriptor. And I need to include not the file system, but rather pipe. All right, pipe down, everybody. Did it work? Who knows? How do we know? Well, it should have shown something here, actually, if it did. So clearly it didn't. Created pipe for file 259. So it should have created a pipe. That part, I believe, worked. Now, yeah, if it gets to this point, that means it worked. Except nobody's writing to the damn console, are they? I don't think anyone's writing to the console. Nobody's writing to the console. All right, but I can write to the console. Okay. So simple, right? To console. My buffer is just going to be hello world, and my size is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That did not work. Okay, now the question is the simple write connected to the console? No, it isn't. Um, okay. Now I can actually implement not console write. Oh wait, you were writing to the console. Oh no. Oh damn. That sucks. Oh, but since you're doing it directly, that doesn't count. So no. There you go. Now, the module itself, you use console write file descriptor and simple console write. Ugh, I hate reading things like these because they're so crazy to tell exactly what the problem is. I'm initializing with a const char. It should have been a const void. Oh, I'm so sorry, Your Majesty. Didn't realize typing was so strict in C. All right. RAM prices are insane. TDR 464 200. What? Oh my god. Funnily enough, RAM is one of the two things that I didn't upgrade on this computer. Well, not on this one. On my gaming computer. Though I think I have enough. But yeah. Oh well. Sucks to be me, I guess. $157. Oh. That comma shouldn't be there. Hey. Road to random hello world end of file. Holy shit. On the second try. Perfect time to sell my old laptop RAM. Oh yeah, I don't have any RAM. But shit. What happened to downloading more RAM? What happened to that? That used to be a thing. We should have listened. Okay, the pipes worked. Tell the pipe demon. The pipes worked. Extremely cool. Very smooth sailing today, I'll say. Incredibly, suspiciously so. If it wasn't because I got tangible results, I would be on edge right now. But, goddamn, I am God's chosen programmer, or whatever Terry Davis said. Okay, we're not saving this. Goodbye and thank you for joining. Although there is that major limitation of the file descriptor cursor thing. You want to seek to the end of the file most likely. Because like, well, unless I only let one person write at a time, which is what I was expecting to do at the beginning, but yeah, most likely. I'll just do that. And if you really wanna have multiple people write at the same time, then you have to take care of your cursors. You have to make sure you synchronize your cursors. But for the time being, we can say limit one writer per file. So I'm just gonna update the note that I took. I'm gonna put it here instead in the right. Hold on, let me put it. This is an open file thing. Okay, there. So I'll either implement an exclusive write. You can request an exclusive write permission, read-only permission, or a non-exclusive write permission. If you request non-exclusive write permission, then it's up to you to keep yourself synced to whatever you want to write. Like, for example, if you're writing to a log file, multiple people can write to the log file. They just write to whatever is the end of the file, but they have to seek to the end of the file before they do that. But they know to do that because they requested a non-exclusive write. If instead they request an exclusive write, only one of them is granted. Seems like a good plan for next time. All right, I need to remember on Friday, 4 days from now, with my goldfish memory, I need to remember that this is what I want to work on. Yeah, RAM saturation is crazy. What is even leading to that? I have no idea. Bought 64 in April for 169. Now the same is 483. Jesus. Who's buying up all the RAM? AI hardware is eating all the chips. God damn it. Fucking AI. It's always AI. It's always AI. This is just the one evil of the world. Hell no. I wish it was the only one. Okay. So, I'm going to take notes, as a matter of fact. This is not getting saved. This is, okay. Pipes. Simple, easy. Boom. Okay. Here's the two things that I need to work on when it comes to the three things that I need to work on when it comes to the file system before I can consider this file system refactor to be done. Number one is listing files. There's currently not an amazing method for that. Well, there is a method for doing that, but I recently refactored it. And because that refactor was pending for a really long time, and then I recently did it, I didn't bother implementing listing the contents of a directory for a really long time, and now I need to implement that. The write, non-exclusive write, and read-only permissions for files, like I said before. And finally, there's even a possibility that a module can allow any kind of permission. It doesn't care about permissions, like is the case for the console. The console or the random, well, random doesn't allow you to write at all, actually. Yeah, random won't allow you to write at all, but it will allow you to read. And console will allow you to do whatever you want because it only works automatically. It doesn't use file descriptors, so it will ignore whatever is in the file descriptor. So if you want to request a exclusive write or a non-exclusive write or read-only permissions and then write, it doesn't care. You're welcome to write. Well, actually, the file system will care, but the module itself won't care. Some others will enforce rules like, okay, if you have a write-only permission, you can only write. You cannot. Only you can write. If you have a non-exclusive, you and others can write. It's up to you to keep track of that and keep in sync. And no, read-only just means that you don't intend to write to the file. So we will block read operations, but also, yeah, since you're not planning on writing, it's very likely that we'll allow you to. Whereas instead, if two people are trying to exclusively write to a file, we won't allow that. We won't allow you to exclusively twice, so you can't open it twice for writing exclusively, but you can do it non-exclusively. Read-only is just, I don't intend to write, essentially. Okay, and the last thing that I needed to implement, I probably shouldn't have yapped so much about this one because now I lost track. Yeah, there was a little bit of stutter. I lost track of the last thing that I needed to do. It is actually a to-do that was in here. Oh, closing files, closing files. Actually, here's how I'm gonna do it. There are 3 errors that I'm not going to commit, but they're gonna stay here. So I'm going to remember that I have to implement these things before I move on. Okay, so on Friday, I'm probably gonna stream these 3 things. Probably Saturday as well. Most likely next Monday, I'm gonna start working on something new. Give me enough time to do this stuff. Because we are reaching the end of the stream today. Maybe throughout the week I'll do like a chill little gaming stream. So I want to keep checking out that hacking game. That looked really interesting. What else? That should be it. Okay. So that's the end of today's stream. If you're interested in seeing that hacking game gameplay, the game is Greyhack. Then stay tuned because I will schedule a live stream, but I don't know when yet. So stay tuned for that. And if not, the next stream for this is going to be on Friday. Game development stream on Sunday. But Friday at 7:30 p.m. No, not UTC. CET, same time as today. Oh, it's right there. That one, 6:30 p.m. UTC. Thank you so much, banner thingy, for being so useful. Okay, and with that, I am going to sign off, and I will see you on Friday.